So now you know the amount that a mole is. It is this 6.022 times 10 to the 23rd discrete particles. Now, we usually only use this when we're discussing really, really tiny things like atoms, ions, isotopes, molecules, things that are very, very, very small. I mean, if you wanted to use it to count eggs, you could try. It's just that no one is going to be transporting this large of a quantity of eggs. The number is so huge, it's hard to put a scale in your head about what it really means. But even if you had a dump truck full of sand to the very top, that number of sand particles would be nowhere near this number. Kind of to show you like how small something has to be for this number to be very practical to use. But it's great for things like atoms and molecules. So we have a really important relationship that we're looking at, and it has to do with the mass of something. Now, I know you can't see these pictures from the side. It would have been helpful because then you can see how high they're mounted. And obviously you can tell like some of them are more powdery than others. But if you were to get a container of zinc and you were to start pouring it out, there's a calculation you can do to find out how much makes a mole. And it turns out that it's this quantity of zinc that makes a mole. It's only this quantity of carbon that makes a mole. So you might be wondering why. And it's because zinc is much, much larger than carbon. It has way more protons. It has way more neutrons. It just is much larger than carbon. So just kind of like if you are trying to compare, 100 bowling balls versus 100 ping pong balls, the bowling balls would weigh more. So when we're talking about moles, we're talking about like the number of things. We're not talking about how much their mass is. But the mass is very important. So you can tell we've kind of got some different numbers in here. We've got magnesium, we've got copper. You're probably familiar with that. And of course, this one's really quite large, the 207 grams of lead. So we have a tool that makes all the difference in the world for these numbers, because trying to remember those numbers or have those numbers, it would be ridiculous. This is why we have the periodic chart. So you'll notice this amount of lead, and it matches with this element down here. This is lead. And you'll notice that on the periodic chart, I don't have to remember that lead is 207.2. It's there. It's already been calculated for you. So when we say a mole of something, what we're really saying is this square right here represents 1 mole, and it has information in it to tell you how much the mass of that 1 mole is, 207.2. We're going to look at another one. We'll look at tin. So tin matches up down here to this one. Again, the square is 1 mole, and that's the mass of it. And then if we also do it with the silicon, go on over, you can see again, this matches with the mass of 1 mole. So a square on the periodic chart represents a mole of something. Now remember, you already know that this also represents, if someone were to count out all the particles, that many atoms of silicon. So there's the little shortcut there that tells you how much that many atoms, it tells you what their mass is. 6.022 times 10 to the 23rd and 6.022 times 10 to the 23rd. So that means that we have some new relationships that we can use for factor label. Yes, you can say that this many atoms is equal to a mole. You already learned that. But now you can use the periodic chart. Just you've got to find the right symbol. But you can use the periodic chart to say that a mole of something is equal to a gram of something. And you can use that in your conversions. So again, you already knew this many atoms was a mole because of the earlier lessons. Now you know that for silicon, remember it's that top one up here. That's how much its mass is, 1 mole's worth. And then for tin over here again, that's a gram. You already knew that many atoms, and now we're talking about grams. So now on, make sure that you have a copy of the periodic chart printed, saved on your phone, saved wherever you need it, because you will use this and what we're teaching right here in this chapter, as well as in chapters 6, 7, 8, and 9. So you're going to use it again. It's not going away.